Hello and welcome, and in this video we'll be graphing systems of linear inequalities, okay? This is a continuation of our systems series, okay? Now, if you haven't watched my video on graphing linear inequalities or my video on graphing linear systems of equations, make sure you do that, okay? Both of those together is how we're going to be graphing systems of linear inequalities. I will put a link in the description below for each of those videos, all right? Now, what is a linear system of inequalities? Well, remember, a linear system of equations was just two or more equations, so a system of inequalities is the exact same thing. It is just two or more inequalities, all right? And the way that we solve these is actually by graphing them, okay? Now, I'm not going to go over how to graph an individual inequality, so make sure that you watch that video. Otherwise, this is going to seem very confusing because I'm going to kind of speed through graphing these inequalities, all right? But what we want to do is we want to graph each of these inequalities in the same coordinate plane, okay? Now, remember, when we graph inequalities, there's only two differences between graphing a line. Is the line going to be solid or dashed, and where are you going to shade, above or below? So I recommend graphing both of these. I like doing it in different colors just so I can kind of see where our answers are going to be. You don't have to, but I recommend when you're shading, shade kind of lightly, okay? That way, when it overlaps, it's going to be a lot more clear where that overlap is, okay? So I'm going to go ahead and graph each of these inequalities. So I'm first going to graph y is greater than or equal to -3/2 x minus 7. Remember, all you need to do, what's your slope, what's your y-intercept, all right? Plot those and go. So let's go ahead and graph this. All right, so that is our first inequality graphed, all right? We had a negative slope, that's why it's going down. It was or equal to, that's why it's solid, and it was greater than, that's why it's shaded above, all right? Now, remember, I recommend shading this a little bit lightly. I can't on this, but I recommend that you do so, all right? Now, remember that all the solutions to that individual inequality are in the shaded region. But we have a system here, so we actually have to graph the other inequality. So I'm going to go ahead and do that now. So I went ahead and graphed that inequality as well. It was or equal to, so it's a solid line, and it's greater than, so I shaded above the line. And remember, all the solutions to that inequality are in its shaded region. So now you might be asking yourself, well, what's a solution to this system of inequalities? Now remember, the solution to a system of equations was where the lines intersected, but that's not necessarily always the case with inequalities. With inequalities, a solution is any point in the overlapped shaded region, okay? So notice in this region in here is where that overlap occurred. Let me go ahead and put a different color in. So in this region here, notice that all the overlap was. So all the shading overlaps in this region here. So what that means is that any point in that shaded region is a solution to the overall inequality. So if I ask, hey, what would be a solution to this system? I could say that the point, let's say -6, +7 would be a solution. -6, +7, because it's in that overlap shaded region. I can also say that, let's say -9, +10. -9, +10 would be a solution. I can say that -3, +9 would be a solution, because all of those are in the overlap shaded region. Any point not in that overlap shaded region is not a solution to the entire system, okay? So that is how we determine what a solution to a system of inequalities is, all right? Any point in that overlap shaded region. Now, it doesn't necessarily only need to be two inequalities. We can throw 3 at you, 4, 5. We can throw 37 at you if we wanted to. I'm not going to, but just know that you could. However, I do want to take a look at one that's just a little bit harder, 3 inequalities. So let's go ahead and take a look at an example like that. All right, so now we have a new linear system of inequalities, and it has 3 inequalities, but don't stress. You tackle this the exact same way. Take it one inequality at a time, and it's really not that bad, okay? So I'm going to go ahead and start graphing these linear inequalities. So I'm going to go ahead and take a look at the first one. All right, so that's our first inequality graph. Notice it had a pretty crazy slope, 2/5, so we weren't able to graph that many points, and it wasn't or equal to, that's why it's a dashed line, okay? Now the next inequality, notice it's just y less than or equal to 3. That's just a horizontal line, okay? It doesn't have a slope, and its y-intercept is 3, so let's go ahead and graph that one. So that's our second inequality graph, and you should already start to see this region where the overlap solutions are, okay? Notice I'm already contained to just this kind of triangular region here. That's where my current solutions to the system lie, but I still have one more inequality I need to graph, and that's this one right here, x greater than -3. Now, this does not have a slope. Its slope is actually undefined, and that's because it's a perfectly vertical line when x is -3. So let's graph that one. All right, so that is x greater than -3 graph. Notice you're no longer thinking about, am I shading above or below the line, because it's a perfectly vertical line. Just think about it logically. Where is x greater than -3? Well, when x is 0 or 6 or 10, so to the right of -3. So that's why I graph to the right. And now it might be a little messy to see on my graph, but hopefully yours is a little bit nicer if you're using just kind of light shading. I'm not able to with this system I got here. But you should kind of notice that it's in this kind of little triangular region here. So I'm going to go ahead and see if I can do that in a different color. So notice that all the overlap is in this region here. So all of the points in this triangular region that I'm shading over again, this is where our solutions to the entire system are, okay? So any point in that region, so it could be the point 0, 0, 0, 0 is in that shaded region. It could be the point 1, 2. It could be the point -2, -1, okay? Any of the points in that overlap shaded region is a solution to the overall system of inequalities, okay? Now, make sure you are practicing systems of inequalities. There are quite a lot of applications of these, okay? Some of which involve something called linear programming, which is super cool, and unfortunately, my school doesn't cover it anymore. I don't know why. I think it's pretty interesting and pretty useful. But if you're one of the lucky schools that actually still cover linear programming, make sure that you 100% practice systems of inequalities, okay? And that's almost it for systems. All I have left is a couple of application videos and then our wonderful 3-variable system. So I hope this video was helpful. Sorry that it was a little messy there. All right, but I hope this video was helpful. If you have any questions, please feel free to let me know, and I'll see you in the upcoming videos.